We use the internet all the time, right? Every single day. But have you ever actually stopped to wonder how it works? I mean, really works. It feels like magic. But today, we're going to pull back the curtain and see the machine behind the trick. It all starts with that one simple action, a click. And in that tiny fraction of a second, an absolutely mind-boggling journey kicks off, spanning the entire globe. So let's zoom in on that moment. What is actually going on in there? All right, first things first, we've got to bust a huge myth. The internet isn't some magical, mystical cloud floating up in the sky. It's a real physical thing, a machine, and it is massive. On one hand, you've got what we all kind of imagine, right? This idea of the cloud, everything being wireless, maybe a little bit of tech magic. But the reality, it's way more down to earth. The internet is really a network of networks, all connected by very real physical cables, and everyone agrees to follow the same set of rules. And get this, when you send an email or stream a movie, there is a very good chance your data is literally flying through thousands of miles of fiber optic cables resting on the bottom of the ocean. Yeah, for real. That Wi-Fi you're using, that's just the very last tiny hop in an enormous wired journey. Okay, so if it's a physical network, who's doing all the talking? Well, at its very core, everything you do online is basically a conversation between two key players, clients and servers. First up, you've got the client, and that's you. Or to be more specific, it's your device, your phone, your laptop, your smart fridge. If it's asking for something from the internet, it's a client. And on the other end of that conversation, that's the server. Think of it like a giant, super powerful computer that's just sitting there, waiting. Its whole job is to store stuff, like websites, and serve it up whenever a client like yours comes asking for it. And the whole interaction is just this super simple back and forth. It's like a two-step dance. Your client asks for a website, that's the request. The server sends the data back, that's the response. Request, response. That's it. That's the heartbeat of the internet. But hold on a second. That brings up a pretty big question, right? How does your device know which server to ask? That's where something like an address book for the entire internet comes into play. I mean, seriously, think about it. There are billions of devices connected to the internet. Sending a message to one specific server is like trying to deliver a letter to one specific house in the entire world without a map. How on earth does it work? Well, the answer is that every single device connected to the internet, your phone, that server in another country, has its own unique mailing address. It's not a street address, though. It's a string of numbers called an IP address. It's how computers find each other. Now, let's be real. You and I are not about to memorize a bunch of random numbers for every website we want to visit. And that's exactly why we have the DNS, the Domain Name System. It is literally the internet's phone book. It takes a name we can remember, like google.com, and translates it into the IP address that computers can understand. So our computer has the address. It knows where to send the message. Now for the really cool part, the incredible journey your data is about to take. See, the internet doesn't send a whole website to you in one giant file. That would be super slow and unreliable. Instead, it does something brilliant. It chops up the data into thousands of tiny little pieces called packets. Each of these packets is like a tiny digital package. It's got a little piece of a website, the ship-to address, that's the IP address we just talked about, and, crucially, instructions on how to put everything back together in the right order when it arrives. And here is the part that just blows my mind. Those thousands of packets don't all travel together. They scatter. They can take totally different routes all over the world to get to you. This is what makes the internet so incredibly tough. If one path gets blocked or has a traffic jam, the packets just find another way. So, who's directing all this controlled chaos? These amazing devices called routers. They are the traffic cops of the internet. They look at each packet's destination address and point it in the right direction, always trying to find the most efficient path at that very moment. So you've got clients, servers, addresses, and packets zipping all over the place. How does this not just turn into total chaos? Well, it all comes down to everyone agreeing to follow a shared rulebook. These rules are called protocols. You've probably seen letters like TCP/IP or HTTP before. Think of them as the shared language that every device on the internet agrees to speak. They make sure packets are sent, received, and put back together correctly, and they even handle errors, like if a packet gets lost. It all happens seamlessly, without you ever knowing.
So, how does this insane global journey feel like it happens in the blink of an eye? Well, it's a mix of a few key things. We've got those super fast fiber optic cables, the genius idea of breaking data into packets so they can travel at the same time, servers that are often located physically closer to you than you think, and those smart routers always avoiding traffic jams.
Which really brings us to this one core idea. The internet is not magic. It's a carefully, brilliantly designed system built to move information. And it all works because of rules, a design that expects and handles failure, and cooperation on a global scale. It's not magic, and honestly, understanding that makes it even more incredible.